Well, it feels like we've been almost done with this project for months now. We had to wait on some parts to arrive, and we hit a couple of last-minute snags. More on that in just a minute. But we finally made it, so today I'm going to show you guys how to put together version 3 of the mintyPi. Now, before I get into it, I've got a couple of quick updates for you. If you follow Helder or me on Instagram, then you may have seen a recent post about an issue that we found with the charging indicator LED. The LEDs that were used in the production boards from the factory wound up having a different pinout than the ones that were on the prototype boards that we've been working with. But don't worry, there is a fix for it. Helder is actually applying it by hand to each and every one of them. I feel pretty bad for him because 1,000 of those boards got made, but it's not a huge deal in the long run. Functionality is pretty much identical. The only difference is when the battery is finished charging, it will turn off instead of changing colors. So he's been hard at work on fixing those over the last few days, and he and I are both planning on starting to pack up orders this weekend and start shipping them out Monday morning. On a more positive note though, we're doing a giveaway for the mintyPi that you'll see me put together in this video. So if you want to enter to win that, check out the link in the description and there should be an entry widget along with links to all the parts and tools that I use in this video. I'll also put a link to the STL files and some tips for printing them out if you plan on doing that yourself. And finally, if you missed out on pre-orders for Helder's parts, there will be another smaller batch of them towards the end of March. So if you want to get in on that, go to his website, follow us on Instagram, check out the Discord server. All of those would be good ways to make sure that you don't miss it. All right, so let's get started. I kind of went through this in the previous update video, but these are the parts that we're going to be using. We've got a set of 3D printed parts, quite a bit different than the previous version, and as you can see, multicolor prints are now an option. A set of screws to hold everything together, and also a magnet which will go in the bezel so that when you close the lid, it will trigger this Hall effect sensor and safely shut down the system. A 3D printed hinge, pretty similar to the previous version. Some custom silicone buttons. I saw a lot of people that seemed pretty skeptical about these, but I'm really happy with how they turned out. They're nice and responsive, and they don't get stuck in the printed parts like the previous version did. I think they feel great. A set of Helder's parts, including the button PCB, which now has power and function buttons built in down here. On the back are the components for boosting to 5 volts, as well as our audio components, which now includes an optional headphone jack. This smaller board goes in the bottom of the tin and takes care of charging the battery. It's got springy battery connectors for use with the new battery that we're using, which is 2200 milliamp hours, up from 1200 on the previous version. So huge improvement there. It also uses USB Type-C and has a charging indicator. Those two boards attach to each other using this connector here, so no soldering required for that part. Same speaker that we used in the previous version, only this time it's included with Helder's parts. L&R button board, this will attach to the battery charging board. A 2.6 inch IPS screen up from 2.4 inches on the previous version. It has a new ribbon connector on the back that we'll use to connect it to the button PCB. It's also got a special button next to it. Right now I've got this saving state when you're playing a game and loading state if you press it while holding the function button. Then of course the Raspberry Pi Zero W. You can use it with a non-W, but I'd recommend spending the extra $5 to get Wi-Fi. And then the Altoids tin itself. There's a 3D printed drilling guide that's included with the printed parts kit this time. It snaps onto the bottom so you can mark exactly where you need to drill and file for various ports and buttons. And we'll also use a few other bits like some flux for making attaching the Pi to the PCB easier, some wire for connecting the speaker, VHB tape for securing the screen into the lid, and some capped on tape to cover the Pi and the button PCB, make sure we don't short anything on the tin accidentally. You'll also want a set of files for getting the tin ready. I'll start with attaching the Pi to the button PCB. This is how they come from the factory. Obviously you'll only get the number that you ordered, but after separating them there can be bits of these tabs left over. So snip those off and file them down. This is especially important for the bottom board as it'll be pretty tight in the printed part that it sits in. So for actually attaching the Pi, it's easiest to screw both boards into the 3D printed faceplate to help line them up. To attach the button PCB, use 3 M2 screws that are 3 millimeters long. Those are the shortest ones that come in the kit. They go here, here, and here. Now when you mount the Pi, make sure that you have it oriented like this. I've seen several people make the mistake of attaching it upside down like this. This will not work and you're gonna have a bad time trying to remove it. but I'll give you some tips in a minute if you do mess it up. So again, make sure that it's like this with the ports facing the printed part. In fact, there's even a cutout here for the HDMI port. But before we screw in the Pi, add some flux to each of the pads on the button PCB. It'll be a little bit messy, but that's fine, we'll clean it up after we're done. Just make sure that each one of them is covered. Use two M2 screws that are 4mm long. Those are the middle ones that come in the kit. They go here and here. But before tightening them all the way, take a moment and make sure it's lined up straight. You can use the row of test pads above it as a reference. Once it's straight, tighten it down all the way. I recommend using a couple of clamps like these ones to press the two boards together. Just don't use ones that are too strong or you'll break something. Now, I get asked frequently what kind of solder I use. A lot of it is personal preference, and I don't think the brand matters too much. I like to use 60/40 rosin core solder, and I like the thinner diameter that makes it easier to get in the pinholes. Soldering iron tip is another thing I get asked about a lot. For stuff like this, a thinner one is better, again, so you can fit it in the pinholes. So start on the sides, heat up the edge of the pinholes and feed a little solder down into them. Then stick the soldering iron tip into the pinhole and press it there for a few seconds before pulling it out quickly. The goal is to get the solder to melt and flow down and make contact with the pad underneath it. I usually do the 4 on each side, then a few in the middle, and then do the rest. This is about what it should look like when you're done, and notice I didn't use a ton of solder on each hole. Make sure it's relatively smooth and you don't have any sharp blobs of solder sticking up that could press against the battery. Now we can clean off the flux from both sides. Now we're going to check for continuity on each of the pins. A multimeter with a beeping continuity mode is really helpful for this. We'll test between each of the test pads above the Pi with the pinholes on the Pi itself. For example, this one is the B button. We get a beep, so we know that we've made a good connection. Here's a reference for which test pad goes to which pad on the board, so you can pause it here while you're doing that. If you find a pinhole that you do not have continuity on, my go-to fix for this is to take a piece of wire, tin it, heat up the pinhole that's giving you problems, and insert the wire. Kind of wiggle it around a little bit and remove it. Most of the time that will help the solder flow from the pinhole to the pad below it. You should also go back and check continuity between each pinhole and its neighboring pinholes to make sure that you haven't shoved too much solder down into there, which can cause it to squish out underneath and make connections with neighboring pins. The only two adjacent pins that should actually have continuity with each other are these two 5-volt pins. Now, if you did bridge a couple of pins, there are a few things that you can try. First is a solder sucker. As I've shown in previous videos, you push the plunger in, heat up the solder, press the tip up against the solder, and press the button. This will suck out some of the excess solder, and doing this a few times can help pull the excess out. Another tool you can try is a desoldering braid. Press it against a pinhole that has too much solder in it and heat it up, and it will wick some of the solder into itself. If all else fails, if you just fed too much solder into there, or maybe you accidentally attached your Pi backwards or something, your best bet is to remove the Pi altogether, clean it up, and try again. This can be tricky because you need to heat up all of the solder at once and gently separate the boards. To make this easier, there's a product called Chip Quick. This is essentially a solder alloy with a very low melting point that you can apply, and it'll be much easier to get all of the solder into a molten state in order to remove the Pi. It comes with some flux, I don't think it's anything special though, and then there's the alloy itself. It's pretty expensive as far as solder goes, but it comes with enough to do a few Pis at least. And there are some off-brands out there that I think are essentially the same thing, but I haven't tried them. So I'll show you how to do it on a really old mintyPi prototype board, actually one of the first boards that Helder and I worked on. First, apply the flux in all of the holes. Again, I don't think their flux is anything special. Then apply some of the solder in each of the pinholes. You might be able to work quick enough with a soldering iron, but a hot air gun will make it much easier. Heat it up all the way and you should be able to gently separate the two. Even so though, you may lift a pad like I did here, and if you do that, what you can do is after you reattach the Pi, run a wire from that pin on the Pi to the corresponding test pad on the button PCB to make that connection again. Now I'll add my headphone jack. If you want to skip that, you'll need to put a blob of solder on these two pads labeled skip so that they are joined together. That will reroute the sound directly to the speaker and bypass the headphone jack. Position the headphone jack, add some solder to one of the legs, And then while maintaining heat on that pad, make sure that you have it lined up properly. Then add solder to the other legs. Now would be a good time to connect the screen. The ribbon cable goes in like this. Temporarily connect the speaker. Pop in an SD card with the mintyPi image on it and make sure everything's working. Now let me go through setting up the SD card real quick because I see a lot of questions about that. Put your SD card into your computer. Download an app called Etcher from etcher.io. You can get it for Windows, Mac, and Linux. Drag the mintyPi image onto it. Select your SD card and hit flash. The image doesn't come with any games on it, but you can either rip your own or find them pretty easily with Google. After a few minutes, you should see a drive pop up on your computer called boot. Open that up, and there should be a file called WPA supplicant. Open that up and edit it. Put your Wi-Fi network name and password in there. Make sure you keep the quote marks around them, and then set your Wi-Fi country here at the top if you're not in the US. Save that file and pop it in your Raspberry Pi and plug it in. You should see a white screen followed by a black screen once it loads the screen driver, and then you should see some logos for RetroPie, Emulation Station, and mintyPi itself, which will also tell you if your sound is working. Once it boots up all the way, you can test out your buttons, make sure that they work, and then take the magnet that we'll put in the bezel, hold it up to the Hall effect sensor, and it should shut the system down for you. Next, we'll get the tin ready. Just like last time, we're going to place the drill guide on the bottom of the tin so that we can mark where we need to drill and file. This is for the micro USB port on the Pi itself, and this is for the headphone jack. Again though, these are both optional, so if you don't care about them, you don't have to bother with them. On the side is the USB Type-C port and charging indicator, and on the back are the L&R buttons. Now this tin right here is pretty cool. Helder recently got a pretty powerful laser for cutting and engraving, which he used to precisely cut this one. He's planning on offering these in small batches, so if you want one of these, keep an eye out on his website and sign up for the waitlist if they're out of stock. I expect he'll be doing some pretty cool stuff with that laser, like this engraved dog tag that he sent me, so definitely give him a follow on Instagram. Alright, so cover up the lid with some masking tape so we don't scratch it up. Put the drill guide on, and it helps if you tape it in place. And use a fine tip marker to outline the USB ports. This is just a rough outline of the shape and location. We'll be checking it with the boards themselves as we go along. Use something sharp to mark where we need to drill the circular holes. This can be a little tricky to do by hand because you need to make sure that you insert whatever you're using perfectly straight, so just be careful as you do it. If you have access to a drill press, that can help a lot. I cut this piece off of a safety pin and used the drill press to make sure that I was marking it right in the middle of each hole. For the charging indicator, if you're careful, you can actually just poke a hole all the way through the tin and be done with it without needing to drill it. So I've marked the locations of the headphone jack and L&R buttons. Now we need to actually drill them. I've tried using a couple different stepper bits, but they all kind of tore up the tin and they just really didn't work well. Instead, what I recommend is taking a set of drill bits and starting with the smallest one and working your way up one step at a time until you get to the correct size. For the L&R buttons, that's going to be a 3/16 bit, and the headphone jack will be a 732 bit. Again, you can do all this by hand and it's the same process, but if you or a friend has a drill press, it will help a lot. Now this part is tricky, so take your time, especially when you start getting to the bigger drill bits, or you'll end up tearing a hole in your tin. Good thing they're cheap and they come with free mints. For the USB ports, I drilled a few small holes in each of them just to get them started. For expanding and shaping these, I'll use some small hand files. This is the set that I use. Getting a set like this that comes with several shapes and sizes is incredibly helpful for this part. It can be a little tedious, but take your time, it's worth it to get nice clean holes. It's helpful to periodically put the drill guide on and even put the PCBs in there so that you can check how you're doing and how much farther you have to go. Now, if you hold up the L&R board, you'll notice that the pads are quite a bit wider than the holes themselves and pretty tall as well. That's so that you have a lot of wiggle room, so that if you don't quite drill your holes in just the right spots, it's okay. Once you're happy with the tin, go ahead and attach the L&R button board to the battery charging board. The two boards line up like this, and we'll add some solder where these pads meet each other to attach them. Gently angle the battery charging board into the 3D printed base and it should pop into place, and then line up the L&R board. Add solder to one of the pads, then heat up that same pad and line it up nicely. Then you can take it out and add solder to the other two pads. When you're done, it should look about like this. Alright, now we can put it all together. First, clean out your tin, make sure you get any metal shavings from drilling and filing out of there, and wipe it down with something like isopropyl alcohol. Put the L&R buttons in. Don't worry, we'll trim them down in a second. They came way longer from the factory than we were anticipating. And now put the base in. We're gonna glue it down. If you just can't stand the idea of using hot glue, this E6000 is the kind of adhesive that I've seen people use on this. Personally, I don't mind hot glue in some situations like this, but to each his own. Make sure you have the ports lined up, add some glue in one of the corners, then double check your alignment and glue down the others. The charging components can get pretty warm, so don't go too crazy there. And now we can trim the L&R buttons down. Your buttons should have come with a small ring that you place over the buttons like this. Take either a fresh, sharp razor or a set of really sharp flush cutters. These are the kind that I have. Cut the excess off at the top of the 3D printed ring. Again, these came from the factory way longer than we anticipated, so this was the best fix that we could come up with, and it works pretty well. And if you were wondering, yes, the flexible 3D printed sleeve from the previous versions still works with these buttons. Insert one end of the connector into the base. There's only one way that it should fit, with these tabs towards the top of the connector, so don't force it. Now we need to get the bezel and the screen back ready. We're going to make sure that the surfaces that will be pressed against each other are nice and smooth. This is important, so don't skip it even if it looks smooth. The lid might not stay open if you don't do this. You can use a file for this, but I like to use a straight razor and scrape it across the surface. Wipe the back down with some alcohol to remove any oils from your fingers. Set the screen back on the bottom of the tin like this. Make sure it's in this orientation. Place a few strips of the VHB tape on like this, and then make sure it's centered perfectly with the tin, and then carefully close the lid on it. Lift it back up and press the printed part down. So now we'll reassemble the button board and faceplate. Attach the speaker with two much smaller lengths of wire. It's easiest if you orient it like this. Add your buttons, then the board. Make sure that your speaker wires aren't pinched in the little wall that goes around the speaker. And screw it all together again. Go ahead and put the battery in, making sure that the metal contacts line up with the pins. And now take your button board with one end of the screen ribbon cable attached to it. I recommend you add some Kapton tape on the bottom just to be safe and make sure we don't short anything on the tin. Carefully attach the connector cable to the bottom. Again, if you're forcing it, you probably have it upside down. Add the screen hinge like so, with the nub facing inward. Now, and make sure you have your SD card in, very carefully angle the whole thing into the tin like so. Use 4 M2 by 8mm screws in all of the corners. Now attach the other end of the ribbon cable to the screen and set it into the back plate. Now would be a good time to turn it on one more time and give it a test. Make sure the screen, sound, and buttons all still work, and shut it down with the magnet. Now go ahead and use a drop of super glue to fix the magnet into the bezel. And this part's a little tricky and the screen is fragile, so be very careful and take your time. Make sure that the screen is seated properly in the back piece. It has 4 tabs that should sit in corresponding notches, and also make sure that the hinge is in the groove that it moves back and forth in. Take the bezel, put your thumb through it to hold the screen in place gently. Start to pop each of the pegs in the corners into the holes. They should snap in with a little force and hold nice and tight. Now, the hinge will be pretty tight at first. Carefully move it back and forth a few times and it should loosen up pretty quickly, but still pop in and out of a locked position when it's open. And you're done. One thing I want to mention real quick about the software. If you go into the RetroPi menu, there's an update mintyPi option just like last time. If we come out with any updates or fixes for things like the save state button or updates to the on-screen function menu, you can run that update option while connected to the internet, and it should pull in any updates that we've released. Alright guys, well if you made it this far, then thanks for watching. If you plan on putting one of these together, then I hope you found this helpful. I know it was kind of long, but I wanted to make sure that I covered absolutely every step. Again, if you want to enter to win this one that you just watched me put together, check out the link in the description and you can enter on that blog post. If you need any help on your build, check out our forums at sudomod.com, or if you want to talk about any of your projects or anything else, we've got a pretty active Discord server as well. Anyway, I'm going to go start packing up mintyPi orders, so I'll see you guys next time.